Hi, I'm Larry Puckett, the DCC guy. Well, today we're finally going to take a look at the new DCC Concepts ESP wireless system that I'm going to be using here on the Piedmont Southern to control the staging yard tracks that I've been building for the last 3 or 4 weeks here on the YouTube channel. I'm going to break this into 2 separate videos. In today's video, I'll give you an overview of the components, how they fit together, how they work together, and then I'll take you through how to set them up, how to program the addresses, all those kind of things, and then make all the connections so that everything will work together properly. And then in the second video, which will come next week, we're going to take a look at how to install those components along with this control panel that I've put together for the staging yard. And we'll install all the components along with the control panel and get them all paired up with the receiver, and we'll be off and running and give it a test drive. In addition, at the end of that, I also want to talk a little bit about the relay that I used with the Illuminator accessory decoder in last week's video, because someone did mention that I did not use a diode across the contacts, the DC contacts, on that relay. And I want to show you that and give you a heads up about why you need to do that and how you do it. But for now, let's go ahead and get started with the video. But first, I want to ask you one more time, hit that little red subscribe button, and when the little bell comes up, click on it and click all. Thanks now. Let's go ahead and take an overview look at the ESP wireless system. And it comprises basically 2 separate components. First, let's look at this one here. This is the transmitter board. And what this does is it takes commands from momentary push buttons or on-off push buttons, or you can use it with toggle switches that are momentary or on-off. And you could also use it with block occupancy detectors to do things like activate crossing gates and crossing bells and warnings and flashing lights and any kind of device that you could control with an accessory decoder can be activated through this particular device. And you'll notice here there are 3 separate inputs here on the board. So that means for each transmitter, you can connect up to 3 inputs, such as the toggle switch or the push button switch or the block occupancy detector. So how could you use this? Well, the first one is what I'm using it for, and that is to do a control panel on my model railroad. But you could also set up, like I've said earlier, block occupancy detectors that would turn lights on the model railroad when a train is in that area. It could be used to control crossing gates for a road crossing. The lights and the bells and flashers, all of that kind of thing could be turned on using a block occupancy detector and an accessory decoder controlled from this transmitter. So I've got these set up for addresses 501, 502, and 503 that go along with the accessory decoders in the IP digital switch machines that I've installed here on the layout. So when I push this button, it would trigger accessory decoder 501 located in the IP digital switch machine for track number 1 in the staging yard and throw that switch machine. For each 3 accessory decoders or IP digital switch machines or whatever devices you want to control, you need to have a transmitter board. So on the staging yard, where I've got 9 tracks, I have to have 3 of these transmitter boards. And these transmitter boards would be placed wherever your control panel is. And I'm building a separate control panel in a wooden enclosure that can be picked up and carried around just like a laptop computer. And you can then send those commands wirelessly to the receiver. So this device here is powered by either DC or DCC power. And with your DC power, it can be anywhere from 12 to 23 volts. And the neat thing is, it'll actually work with a 9-volt battery. And it won't last as long as something with a 12-volt battery or a separate 12-volt power supply, but you can get away with a lot with just a rechargeable 9-volt battery. And we'll see, I'll show you how that works in a minute. So then you could also connect it to a DCC power supply, but then it wouldn't be wireless, would it? And that kind of gets around what we're seeking. The device, as you can see, has a little springy antenna right here, and that is used to communicate wirelessly with the receiver located on the layout. So let's take a look at the receiver. This is the receiver, and you can see right here it's got a little antenna just like the one on the transmitter, and these two can communicate with one another once they're paired. So it's sort of like Bluetooth pairing and the communications between Bluetooth devices. However, they have come up, DCC Concepts came up with their own proprietary communications system. So it's not, it works like Bluetooth, and it's paired like Bluetooth devices, but it is not Bluetooth technology. You can pair an unlimited number of transmitters with one receiver. So there's no limit on that. So you really only need one receiver on your entire layout, and it can be paired with all the transmitters that you want to use to control your turnouts, your lights, anything else that you can control with an accessory decoder. Okay, so this one, it goes on the layout somewhere. You can power this 3 different ways. You can power this with a standalone DC power supply in the 12 to 23 volt range, something like that. And it will create output an accessory decoder power bus. So you can create your own 1.5 amp accessory decoder power bus just using this device and a 12 volt to 23 volt DC power supply to feed it. And it needs no other connection to your DCC system. For that reason, you can use this device with a DC powered layout, an AC powered layout, a DCC powered layout, obviously. So that gives it a lot of flexibility because it allows people who still have their own DC powered model railroads to use accessory decoders and associated devices to control switch machines and lights and crossing gates and everything else on their model railroad without having to switch to DCC power for their locomotives. So that's a lot of flexibility and a lot more people that can use this. Now, assuming you do use a power feed from your DCC power bus to operate and power the receiver, there is one very positive result of doing it that way, because the accessory power output from the receiver will then contain all of the signals that are produced by your command station. And that means that you could use your handheld throttle or a computer program like Panel Pro in JMRI to control the accessories on your model railroad. But it also comes with a downside, because as I said, this can produce up to 1.5 amps for the accessory power bus. But that 1.5 amps will have to come from your DCC power bus if you go that route. So that means you would have potentially less power available to run your locomotives on your model railroad. So there's a third option, as I said, and that is to add a booster to the output from the device, from the receiver. And that way, the additional booster will provide all of the additional power necessary for the accessory power bus and leave the full amperage of your main DCC power bus to run trains with. So those are your 3 options. You can use DC power to power it, you can use DCC power from your DCC power bus, or you can use an additional booster on the output to power the accessory power bus itself. Now, If you do use the 12-volt DC power supply that I've been talking about, that does need to be rated at least 1.5 amps. So you'll need a DC power supply, 12 to 23 volts, and rated at 1.5 amps in order to provide the full 1.5 amps to your accessory power bus on your layout. Now, how does this work? When a command is sent from the transmitter, it's received by this device, and it is converted into the DCC command structure and signal in the same way that it is produced in a command station on your DCC layout. It will then boost that signal to whatever voltage it is being supplied and send that out on the accessory bus wires at this output here. So you can create your own standalone accessory power bus using this device rated at 1.5 amps. Now, given that most switch machines use somewhere between 20 and 40 milliamps when they're operating, and less than 10 milliamps when they're just sitting there waiting for a command, you can power a lot of devices with a 1.5 amp accessory bus. So that's one of the great things about this. It creates its own standalone accessory bus. Now let's go ahead and look at how you set these up, because there are a lot of options here to cover. Now, as I said, you can use various types of push buttons and toggles and block detectors, those kind of things that can be plugged in here. And you'll note here on the board that for each one of these input connectors, there is a plus and a minus indicator. So if you have something that is powered, such as a block detector coming in here, you need to make sure that you've got the polarity correct. And if you get the polarity backwards, the device will protect itself and it just won't work. So you can't blow the board up, presumably, by putting in the wires backwards. It just won't work. Now, what else is located here? Well, as I mentioned, you have the option of going with a powered device or with an on-off device. And that's what this little red jumper is for. You put it this way, and you can go with 3 to 20 volts DC input, put it on this side, and it's a simple on-off type device. Now, the other thing on here is this blue jumper right here for each one of these inputs. Put it on this way, and it indicates that it is a momentary switch. Put it on this way, and it is an off-on switch. So if you're using a momentary push button, you would put the jumper on these 2 pins. If you're using an on-off, like my toggle switches, then it would be on these 2 jumpers. And when the inputs come in, as I said, it sends a command out identified with each one of these addresses, whichever one is being controlled. The command is sent from the transmitter to the receiver for 501, 502, or for 503. How does all this work as far as setting it up? Well, there's a number of things that need to be set up. First, let me show you that right here, this is where power goes in, and it has these same type of removable screw terminals that are used to power it up right in here. Then right here, there is an on-off switch, so you can turn power on and off to the board. After that, the other thing that you're going to do is need to pair it with your receiver. So right here, there's a little push button, and all you have to do is take and set it up to be paired. Now for that, you can pair this transmitter with 2 separate receivers. And I'll talk about why you would want to use a second receiver in a minute. But to pair it with receiver 1, you just put this blue jumper on the on position. It's got an on and an off position. So you put the blue jumper so it covers the 2 pins for on, and then you just push the pairing button on each one. And there's a little LED here on the board that starts flashing. And it also flashes the same way on the receiver board. And that is telling you that it is actively pairing. And then when it has paired with the receiver, then that light will stay on solid. And at that point, that one's ready to be used. Also on the board, just like with accessory decoders, you need to set the addresses for each one of these. Now to do that, you have to connect the transmitter to an active DCC system. So I used it with my NCE power cab and just connected 2 wires from the power cab right in here. And then what you do is you move this little sliding switch right here from the run position to the set position. So if you slide that to set, then all you have to do is enter a command for the accessory address that you want this to be programmed to be identified with. So you move it to here, and then on your power cab throttle, you would enter a command to throw switch 501. And as soon as you do that, you'll see the little light flicker, and that's telling you that it is receiving its command and setting up the address for 501. And the neat thing about this is when it sets 501, it will also set 502 and 503. So it will do all 3 in an ascending sequence. So all you have to do is program address 501, and it will also do 502 and 503 at the same time for you. So that's a pretty neat option, but something that's common with a lot of accessory decoders when they are programmed as well, if you have multiple addresses on them. Then when you're done programming, you just move that slide switch back to the run position from the set position. Let me also point out that here, when you're finished with your pairing, you want to leave the pairing switch set for on for receiver 1. Now, I said that I would tell you why would you want to use a second receiver. Well, let's say you wanted to use LEDs on your control panel or on a larger display board somewhere to indicate that a switch has been thrown. Well, in that case, you would need to have a second receiver that would be connected to a device that controls those LEDs. I'm not going to be using that here on the staging yard, so I'm not going to be able to show you that, but that's what that's for. Hopefully sometime in the future, I've got some ideas for how I would like to use the LEDs on the layout, so maybe we'll get a chance to take a look at how it works with the LED receiver board further down the road. Now let me go ahead and follow through with the receiver board itself because, as I said, like the transmitter, it has an on-off switch right here, so you can turn power on and off. And let me point out that when you're doing any connections on these boards, you want to have power turned off and removed. So you would just unplug the input terminals here for power so that these things are not going to be blown by some inadvertent short as you are doing things here on the board. But of course, when they're operating, you want it all plugged in and turned on. And this here is the pairing switch that I was talking about that you would use to pair with the transmitter. So that's pretty straightforward. There's not a lot to worry about on this guy here. As I said earlier, these devices can typically be powered with 12 to 23 volts, but they will work with a 9-volt battery. And what you can do is just hook up your terminals here like this and plug it in to either the transmitter or the receiver. I'm going to hook it into the transmitter here like that. And that's all it takes to power that board up. So I can turn this board on now, and you can see the little on pilot light is on at this point. Now it's flickering because the receiver is not turned on itself. So let me go ahead and we'll connect that and see what happens. Turn that off first. This device here that I've got is called a power bank. I got this off Amazon. I think it was 25 bucks. And what this is, it is a power bank. It's a 12 volt, and it also has a 5 volt output as well for a USB device. So these are really made for charging your cell phones and devices that can work, recharge off of a 5 volt USB plug. And you can see that right here. This is the barrel plug is for the connection to the 12 volt source, and you can see the USB connection right here. So it makes it very straightforward. It's got an on-off switch and a row of illuminated LEDs to give you an idea of the battery charge status. So this one's fully charged. So I'm going to turn that off, and we'll go ahead and plug it in like this. And then I'm going to attach it to the board. Okay, and now let's turn them on. Okay, turning it on. There. And we'll turn this one on, like that. And you can see they've paired up. There was a quick flash, and they paired up that quickly. So these can now talk to one another. Okay, let me go ahead and let's turn them back off while I make some more connections. Like this. Okay, I'm going to go ahead and add my toggle switch, since that's what I've set it up for. Set up for an on-off device, like that. And then I have a Cobalt IP digital switch machines, like the ones that I've shown you in the past, and I'll put a link to that video here above me, as well as a link to one on the ESP wireless system. But I've got this programmed to address 501, and I'm going to go ahead and plug it in to the output terminals here on the receiver board. Let me go ahead and zoom out a little bit for this. So we now have the 9-volt battery powering the transmitter. We have the 12-volt battery powering our receiver. So let's go ahead and turn those on. Now they've connected, they've paired up, and this is my, let me turn this around so you can see the swing arm here. I'm going to throw the toggle. And you could hear the Cobalt switch machine activate. So let's turn it off, and I'll get back in again. And right here is the little sweep arm that that throws turnouts. So let me do that again. So you can see that's moved back into its other position, and you could hear it running again. So without any connections between the transmitter and the receiver, I'm able to control my switch machine that will be located under the layout on one of those turnouts. Now, just how strong is this connection? Well, the information that DCC Concepts provided me, they said they've tested this at up to 200 feet with a cinder block wall in the way. And in the video that I put a link to, and I'll add a link to that again at the end of this video, they actually show Richard Brighton, the sales manager of DCC Concepts, walk outside of the building and still throw the turnout using the ESP wireless system. So you can use this at train shows and not have to worry about how far you get away from your model railroad before you can't throw switches any longer. Matter of fact, because these devices, the receivers themselves, each have their own unique address, and the transmitters are all powered with the receivers and their unique address, you can mix any number of these in a room and not have any problems with crosstalk or interference. So for you guys that go to train shows and other exhibitions, you can have your control panel all separate from the layout, flip a switch, and you can be up and running as soon as you've got power supplied to your model railroad. Now, there's probably a lot of other things that I have not gotten into on this that you'll have questions about. I know that over about the last month, I've had a ton of questions for the technical guys at DCC Concepts about just how these devices operate and some of the ways that you could actually use these. So go ahead, fire off your comments and questions to me, and I'll try to answer all of them as usual. Okay, let's go ahead now and take a look at the relay and the diode that I've added to it, because that's a very important component. So this is the little 12-volt relay that I showed you last time that I used with the illuminator to control track 9 in the staging yard. And as you can see, I got it from allelectronics.com. The catalog number there is RLY-557. And this is a 12-volt DC relay, single pole, single throw switch. And it has a resistance of 720 ohms. And that's very important because if you divide 12 volts by 720 ohms, you'll find that this has a amperage draw of about 16.7 milliamps, which is, very minimal. So you want something with a higher ohm rating, something in the 700, 720, 750, something like that range, if you can't find this specific relay. And, all of these various companies, Jameco, DigiKey, all of those sell these small PC mount relays. And the way that you find out more about these, they typically will have on their websites a PDF with all of the specifications about these, but you can also just look at the component number here on the printed on the case and look that up using Google or other searches on the internet, and you'll be able to find a PDF or an online source that will tell you how you know which of these contacts are the plus and the minus contacts and the ones that are the switch contacts. And that's something that's important. But you can also just take a voltmeter and use a voltmeter to test this, as well as taking a 9-volt battery and attaching it to the various leads to find out what's plus and what's minus. Because these things are polarity sensitive. They will only work when the 12-volt or the 9-volt battery is hooked up to the proper terminals. So if you get it to go click, then that means you found the plus and the minus terminals. And then what you do is, now this is a diode. It's a 1N4003, I believe it is. And in that 1N series, they are a 1 amp diode, and that means they can take 1 amp. And this is a 4000 series, so it's 4001, 2, 3, 4, 5, 6, 7, that kind of thing. And the last digit is the operating voltage in hundreds. So the 1N4001 is a 100 volt diode. A 1N4003 is a 300 volt diode, and that's what I used here with this. So this is a 1 amp 300 volt diode, and you want something high enough to take any voltages that might come back, because the reason you put these on here is that the little coil in here can store a lot of electricity. And when you shut this off suddenly, that stored energy inside the coil can come surging back out and travel back to your components in your decoder or whatever you're using this with, and it can zap them. So that's why you do it. It's a protector. So you put that little diode in here, and you note that on the diode, let me show you this close, you can see there's a little silver or white mark here on the end of the barrel-shaped diode. That is facing the positive contact on the relay. So that's how you hook it up. So you just solder it to the relays, clip the little leads off short, and then attach your plus and your minus wires from your power source for this. Okay, so that's all there is to that. I hope that answered the questions that came up after the video and that I got in the comments. Well, that's a wrap for today's video. Now, when I first saw the video on this ESP wireless system on the DCC Concepts channel, I was totally blown away with the ability to build control panels without having to string, hundreds of feet of wire to all of the different components that you're going to be controlling. Because this really is a game changer as far as wiring model railroads. So come on back for next week's video where we're going to actually put this all together along with the control panel and get it hooked up to the model railroad and see if it all works. So in the meantime, have a great week, be safe, and we'll see you here with another video from the DCC guy. Bye now.